All right. Gave that about a minute. Thanks everyone for joining. Good afternoon and good morning. I'm Lalani Dunn. I'm the Executive Director of the BBRSDA. Today is our 2026 Bristol Bay Salmon Forecast by the University of Washington Fisheries Research Institute. We appreciate everyone for taking the time to be here as we prepare for another season. Before we begin, I just want to point out that Alaska Department of Fish and Game presented in person in Anchorage earlier in March. And if you weren't able to attend, that information and presentation materials are available on our website. I think Mariah will be putting it in the chat for anyone. And we are also excited to be launching an app, the Bristol Bay Live Run app, in about a month, and it's designed to be a centralized resource for the fleet that will include these forecasts, fish and game announcements, Port Muller fishery data, weather, tides, and any additional in-season info to help you guys stay informed throughout the season. And then following the presentation, we're going to go over a few updates and events ahead of June. So with that, I'd love to introduce Frances Birch, our program director, and she'll be introducing today's speakers and moderating. Thanks.
Thanks, Lilani. Yeah, we're lucky to have two forecasts as fishermen, and we look forward to hearing today the UW forecast and some of the science that goes into it as well. We're going to start with Chris Boatright. He is the general manager and research scientist with the University of Washington Alaska Salmon Program. And I forgot my housekeeping rules with Zoom, but we'll give a pause in between each of the presenters for questions, but also feel free to enter them in the Q&A or chat function. We'll be keeping an eye on that, or raise your hand to ask a question live. And if you are on the phone, you can press *9 to raise and lower your hand. So happy to hear from y'all calling in as well. Yeah, and then we will follow up. Those of you who registered, we have your contact information. So we will send a recording of this presentation as well as a summary of the links that we share in the chat. So if you don't catch them live here, we'll send that over to you afterward so you get a comprehensive information. But again, I'll turn it over to Chris. Thank you so much.
Thank you, Frances. I'll get us started here. Let me see if I can get my screen shared.
We had it and then we lost it.
Okay, let's see. How's that look?
There it is.
Looks great.
All right. Is it... Okay. So thank you, Frances and Lilani and BBRSDA for organizing this. And thanks to everyone who's joining us today to talk about expectations for the 2026 Bristol Bay sockeye fishery. So I think a good place to start with the preseason forecast review is with the table that's up on the screen now. This is really the most basic forecast table we generate. It is, the body of the table are 36 individual predictions. So 36, that is a prediction for each of the dominant age classes of sockeye that return to Bristol Bay each summer for each of the 9 river systems. So our expectations for the Bristol Bay sockeye return in 2026 sits at 41.5 million sockeye. So dominant age classes of sockeye that make up the overwhelming bulk of our forecast are 1-2s and 2-2s, which get grouped together as 2 ocean fish, and then 1-3s, 1-3s, and 2-3s, which get grouped together for many things as 3 ocean fish. And I'll talk a little bit more about that further into the talk. It is really that ocean age. So 1-2s and 2-2s are 2 years in the ocean, and 1-3s and 2-3s are 3 years in the ocean. It's that ocean age that's the biggest driver of the size of the fish we see each year. So to take our expectations for 2026 and place them in a bit of context, what we're looking at now here on screen is Bristol Bay historical production from 1970 to 2025. It's seen in stacked columns, which are the sockeye run summed in each of the commercial fishing districts. So what we see is that across this time series, 1970 to 2025, we had our smallest year in 1973 at only 3.5 million total run for Bristol Bay in that year, and then our largest return of sockeye to Bristol Bay in 2022 at 83 million fish. So on the right hand side, we see our 2026 forecast in that single column there, and we can begin to take a look at how it stacks up to the historical production in Bristol Bay from 1970 until now. So 2026 forecast again at 41.5 million sockeye. That splits into 46% of that is forecasted to be 2 ocean, and 54% of that is forecasted to be 3 ocean. 41.5, that's 32% lower than the most recent 10-year average. So right in here where we had this record-setting production for Bristol Bay sockeye, and it's 18% than the most recent 20-year production for Bristol Bay. However, the fact is that it's right in line with some of this production from prior to 2015. It's just that average really gets pulled up here. The 20-year, most recent 20-year average really gets pulled up by what we've seen over the last decade. So specifically relative to last year, we had 2025 saw an observed run of 57.1 million sockeye, and that was made up of 22.2 million 2 ocean sockeye and 34.7 million 3 ocean sockeye. So the breakdown there was 39% of that is 2 ocean and 61% as 3 ocean. So a lot of 3 ocean sockeye in last year's return. Our expectations is about 54% 3 ocean sockeye for 2026. So from there, we're kind of taking a step back here. This is really the same data set as we were just looking at, but now instead of being stacked columns organized by districts, it is color bands or stacked color bands, and it's broken apart by all 9 major river systems for Bristol Bay. So what we're looking at are Bristol Bay sockeye salmon returns from 1963 to 2025. It is this historical sockeye salmon returns for Bristol Bay coupled with explicit age data for sockeye that's collected every year by the Alaska Department of Fish and Game that is the primary data set that these forecasts are built on. So what we can see, you can see patterns in Bristol Bay production just from the color bands there. For example, if you look at the yellow color band, which is the Kvichak River, what we can see is that it was really dominated overall production of Bristol Bay sockeye for much of the 20th century. By the late 80s into the 90s, overall production of Bristol Bay sockeye really began to diversify between river systems. with Igigit coming on as a major and dominant producer in some years. And then when we move here to these last 10 to 12 years of record-setting production, those are really characterized by relatively strong production across all the river systems, and certainly with the Nushagak and the Wood playing a dominant role in many of those years. So, but for today, we are interested in the next chapter, so to speak, and that is 2026 and how it's going to stack up to what we've seen before. And that brings us to the forecast table as it is released in early November of each year. So over here on the left-hand side is where we started. The individual predictions that sum to get us not only to our forecast for river totals, but our Bristol Bay sockeye forecast or expectations for 2026 at 41.5 million sockeye. To the right of the river totals, we provide our best estimate of the escapement that we would expect in 2026. And so we would expect an escapement very close to 12 million sockeye off a total return of 41.5 million sockeye. Now, to get to that estimate of escapement, we really consider the relationship between run sizes to each of the rivers and the escapement we've seen in the past. We also consider current escapement goal policy and to generate our best estimate of escapement given a Bristol Bay return of 41.5 million sockeye. We also provide an estimate of Bristol Bay fish taken outside of Bristol Bay's commercial fishing districts. And so for 2026, our expectations are for that to be fairly low relative to what has been taken in the past, and that was at 440,000. And we remove both of these from our totals here and come up with our best estimate of inshore harvest. And so we would expect an inshore harvest, that's fish, sockeye taken within the commercial fishing districts, of 29.1 million sockeye off a total Bristol Bay return of 41.5 million sockeye. So certainly to get the most out of any forecast, you have to consider forecast accuracy over some time period, and so that's exactly why we put this plot together each year, is to give some real information about forecast accuracy involved with our preseason forecast. This is a two-panel plot. There's a top panel here and a lower panel. We're going to start with the top panel. So the top panel is simply percent deviation in the UW-FRI preseason forecast from actual return numbers. So for this time series, 2000 to 2025, those actual return numbers each year are set to the 0 line. And then, of course, the columns that fall above or below are the percent deviation of the forecast from those actual return numbers for Bristol Bay. So red columns that fall above would be over forecast in those years, and blue columns that fall below would be under forecast in those years from actual return numbers. And our percent error or average percent error, specifically mean absolute percent error across this time series, is 14.8%. Now the bottom panel here is a bit simpler in the sense that really the blue data points connected by a dotted blue line are, again, the actual return numbers for Bristol Bay sockeye in each of these years. And then the red line that's overlaid is simply our forecast, preseason forecast values in those years. And really, I think what this bottom panel does is just gives an idea of how through time these preseason forecasts track with actual Bristol Bay sockeye return numbers, and we can see that they track pretty well. When starting right around 2015, 2016, when Bristol Bay's returns began to average greater than 60 million, we can see a bit of an under forecast in many of those years, but that gap has closed here in the last several years, and we certainly hope that it remains small here with these forecasts. So one of the things we started doing quite a while back with our preseason forecast, which is in numbers of fish, is we take those numbers of fish. So again, our inshore harvest estimate in numbers of fish at 29.1 million sockeye. And this table, of course, is organized by commercial fishing districts as opposed to each river. And again, still by the 4 dominant age classes of sockeye. And we translate that number of fish into a forecast in pounds. So we've always just referred to this as our preseason Bristol Bay sockeye forecast in pounds. What we would expect off an inshore harvest of 29.1 million sockeye, or specifically 29.06 million sockeye, is a harvest of about 168.4 million pounds in the 2026 Bristol Bay harvest. So in order to get to that estimate or a forecast in pounds, we have to provide an estimate of Bristol Bay, our expectations for Bristol Bay sockeye size in 2026. And so that's what we're looking at here. We are expecting, given a Bristol Bay sockeye return of 41.5, of certainly under 42 million, we would expect sockeye size to come up some from what we've seen over the last decade, with two ocean sockeye averaging 4.9 pounds and three ocean sockeye averaging 6.6 pounds. Now, this is a pretty big jump in what we've seen for over the last decade in terms of sockeye size. So here's the data set that we use to get to that estimate of sockeye size. And so what's popped up here in the middle of the screen with a black background are Bristol Bay sockeye size in pounds from 1980 to 2025 here. This is actually specifically average annual sockeye size for two ocean sockeye, the blue data points connected by a blue line, and then average annual size of three ocean sockeye, Bristol Bay three ocean sockeye, red data point connected by a red line across this time series. So for each year, 1980 to 2025. And then highlighted in yellow here are our estimates of our expectations for 2026. So you can see that indeed that is a bit of a jump in sockeye size. If it holds up, I think that's probably good news for most folks. And so how we arrive at that is pretty straightforward process. So across this time series of data for each two ocean and three ocean sockeye, we select the 10 runs, total Bristol Bay runs, that are closest in size to our expectations for Bristol Bay in 2026. And so what you see highlighted in yellow and square data points are those 10 runs. And then for three ocean and then also for two ocean, we simply take a average of those years to come up with average of sockeye size in pounds, to come up with our estimates for or expectations for sockeye size in 2026. These 10 data points, all of these Bristol Bay runs fall within the total run size bin of 38 million sockeye to 43 million sockeye. It makes sense given the simplicity of how this is done. And so obviously the 41.5 million sockeye forecasted for 2026 falls more or less right in the middle of that. So that's the forecast, the 2026 preseason sockeye forecast in pounds. And with that, I'll leave it there for the review of our 2026 preseason forecast.
Thank you, Chris. Yeah, well, I just dropped it in the chat, but welcome any questions. We'll give a minute as we transition screen shares to Dr. Curry Cunningham. Thank you. I learn something every time I hear it, and appreciate it. Yeah, Franz, I see a question there.
Can you hear me?
Yep, you're live.
Hey, thanks everybody. Thanks for that presentation. I have a couple questions with that sizing model at the end there. Do you guys know the accuracy of that? Like you had the percentage for your predictions, but do you have the percentage of your accuracy for those fish size models?
Yeah, so it is for the two ocean estimate. The mean absolute percent error for the last decade runs at about 7.5%, and it's a little bit more than that for three ocean. There's a little bit more variability or variance in the three ocean, and that mean absolute percent error runs right about between 8.5 and 9%. And of course, some years, within that, some years it's very close, and it can get upwards of 20% in some years, but the average for both is less than 9.
I don't know if am I still alive here? Okay. So is that, just to clarify, that's 7.5% under, like your model is 7.5% above or below what actually returns in the size?
Well, it's average. It's mean absolute percent error. So it's not one direction or the other. It's the average of just the percent error, whether it's above or below for each of those years.
Gotcha. Okay. Thank you.
Thanks, Franz. I see another question in the chat from John Wise. He says, you don't distinguish between 1.3s and 2.3s or 1.2s and 2.2s in terms of size. Freshwater size increase aren't significant.
No, it's not significant. The sizes we see are real. I mean, of course, there is a variability in size at age amongst years, but the biggest driver is really ocean age, and so 1.3s and 2.3s really are not. It's going to be negligible within the same year. If you took averages of tens of thousands of fish, you would probably be able to parse out a small, very small size difference between 1.3s and 2.3s, but it's very small.
That's interesting. Yeah, I remember learning that recently and I was surprised. It's a good question. Thank you. Well, let's get started with Curry Cunningham, and there'll be more opportunity. Feel free to type in questions as you think of them, and the panelists can bop around and answer them. They're willing to do that as well as at the end. So don't hesitate if you think of something from an earlier presentation. But I'll introduce Dr. Curry Cunningham. He's a quantitative ecologist with the University of Washington Alaska Salmon Program, and a former Bristol Bay commercial fisherman and a professor at the College of Fisheries and Ocean Sciences, University of Alaska Fairbanks. And he'll be presenting today on the use of Eastern Bering Sea surface trawl survey data to inform the Bristol Bay forecasts. Thanks, Curry.
Yeah, thanks for having me, Francis, and good to see quite a few friendly faces and names in the crowd. So thanks for coming out, everybody, and tuning in. Let's see here. Well, as Chris highlighted earlier it very well, our traditional preseason forecast methods for Bristol Bay sockeye really are based on a couple of different metrics. One, what we think of as cohort or sibling relationships, these relationships between fish from the same year or went to sea in the same year that returned after fewer years in the ocean. So things like the abundance of 1.2s returning in 2025, predicting the abundance of 1.3s returning in 2026 to a given river system. There's information in stock recruitment relationships. Obviously, if there was a very low spawning stock size in the year that should have produced the fish that are returning in 2026, we might expect a slightly lower run and environmental information. And kind of over the years, as our forecast methods have developed, we've explored a range of different ways of approaching those data, from dynamic linear models to machine learning methods like boosted regression trees. But for the last couple of years, and many of you are probably familiar, I've been really interested in trying to think outside of just the sort of Bristol Bay brood tables of adult returns and see what other information we can bring in to inform our preseason forecasts. And more specifically, how we can use data from surface trawl surveys that are conducted by the NOAA Alaska Fishery Science Center in collaboration with the Alaska Department of Fish and Game to inform our preseason forecasts. So really the sort of motivating questions for my talk today are: one, how well do these Northern Bering Sea, Southeastern Bering Sea surface trawl survey observations inform our Bristol Bay run size forecasts? How well does that work at the baywide level and also at the stock level, at the river system level, right? And then what is the sort of predictive power of these survey data or predictions based on these survey data relative to our maybe traditional forecast methods, those sibling relationships, spawning abundance information, and so on. And then I'll just quickly highlight some of the UW FRI in-season forecast products that we build during the season and try to make available to all of you in the fleet and folks on the processing side as well. So in terms of background, NOAA has conducted surface trawl surveys in the Northern Bering Sea and the Southeastern Bering Sea since about 2002. These surveys take place in sort of September into October, and really provide an index of juvenile sockeye salmon abundance, in addition to other salmon species and other species out in the marine environment, in that period just after freshwater entry. So it's basically an index of juveniles that have survived freshwater and early marine mortality. One of the reasons these data are useful from a Bristol Bay sockeye perspective is that although there are other river systems, the Kuskokwim being one example, that are producing sockeye, Bristol Bay is, of course, the dominant producer. So most of the juvenile sockeye that are caught in these surveys are probably out migrating from Bristol Bay and likely to return to Bristol Bay in the future. There's a couple challenges in working with this data. I won't go into too much detail, but really this is two separate surveys. The Northern Bering Sea is surveyed every year for the most part. The Southeastern Bering Sea is surveyed in alternating years. And so one of the challenges we have to deal with and leverage some statistical methods to do is to deal with this sort of what we think of as spatial imbalance in the data. If you're interested in those methods, we can talk more about it later, but it's similar to the methods we use for kind of weaving together intercalibrating data from other surveys for groundfish and other examples. But what the result is at the end of that are basically predictions for what we think of as the abundance density, or the approximate number of juvenile sockeye per square kilometer that this surface trawl has traveled the Eastern Bering Sea across years. So up here in the top, this is the year of the survey. Down in the bottom right, these are the primary years that those fish that were caught in that survey. So in 2002, most of the fish are going to return as 2 ocean fish in 2004 and 3 ocean fish in 2005. The more yellow colors are higher relative abundance of juvenile sockeye. The more blue colors are lower relative abundance of juvenile sockeye. And so you'll see spatially, right, the majority of them are caught kind of outside and around Bristol Bay, extending northward in some years. But as you look at it, you'll tend to notice that there's a couple periods of time with kind of more blue versus more yellow, right? Just to make that a little clearer, this period of time between 2008 and 2013 had lower abundance, or at least lower abundance of juvenile sockeye were observed in surface trawl surveys. Beginning at about 2014, there was a higher abundance, more yellow in these figures, higher abundance of juvenile sockeye observed in these surface trawl surveys between 2014 and up through 2019. There was no survey in 2020 due to COVID. And then in 2021 and into the future, a kind of a slight reduction in the number of juvenile sockeye encountered, and as a result, the model predictions for juvenile sockeye abundance. So what we can do is kind of translate these sort of spatial predictions for juvenile sockeye abundance based on the surface trawl survey data, sum things up across space to get an annual index of juvenile sockeye that are out there in the Eastern and Northern Bering Sea year over year. So this is by year, or B, we can think of this by outmigration year. And again, we can pick up these periods of time, kind of higher abundance of juvenile sockeye up here through just before 2008, 9, 10, up through basically 2013, 2014. It starts to increases all the way through 2019. 2019, the highest index of juvenile sockeye observed over the course of the survey, that gap in 2020, and then dropping down after that, up again in 2022, and then a little bit lower thereafter. This is 2025. This is last year. One of the nice things about these data are that these surveys occur in the fall, but colleagues at NOAA and the Alaska Department of Fish and Game have done a really good job of trying to make these data available as early as possible to integrate with the timeline of our preseason forecast cycle, as Chris was talking about. We always try to release our forecast before Expo in November, and we're doing our best to try to sort of make these predictions as early as possible. So one thing you'll notice, again, these bars are kind of the relative abundance of juvenile sockeye out in the Eastern and Northern Bering Sea. As I said before, the highest index was in 2019. This, of course, would have been 2 ocean fish returning 2 years later in 2021. That was our fairly large run in Bristol Bay at about 71 million. And 3 ocean returns in 2022, our record-setting 83 million fish run. So we begin to see this alignment between these juvenile indices and what we saw 2 and 3 years later returning as adults. Of course, at the end of the day, we're all here because we're more interested, I think, in the number of returning adults. And you'll love my spawning sockeye AI-generated image here. But in order to translate our predicted number of juveniles out in the Eastern Bering Sea, this index of juvenile sockeye in the year of outmigration to adult returns, we basically have to combine 2 juvenile indices together to consider the total return or expectation for juveniles that will be returning 2 and 3 years later. So for here in 2026, that would be considering the 2024 index. Those would be 2 ocean individuals returning 2026, and the 2023 surface trawl survey juvenile index for those 3 ocean fish that are going to contribute to the 2026 run. So when we do that, we basically bring together juvenile outmigration indexes from 2 and 3 years ago, combine them together, we can come up with this index that should be related to adult returns 2 and 3 years down the line. So that's what I have plotted here. So instead of thinking about an index of juvenile abundance by outmigration year, this is an index that maybe represents adult returns based on those juveniles caught in surface trawl surveys. So again, we see this period of time a little bit higher, predicted adult returns up through 2020, up through 2010, 2011 through 2015, a little bit lower, increasing here up through 2021, 2022, and then dropping off thereafter. If we look at the relationship between this high seas index of adult returns here on the x-axis and Bristol Bay run size, this is in thousands down here, but Bristol Bay run size in millions. So 2022 being up here, 2021 not far behind it, 2025 over here. We can see the relationship between this high seas index of adult returns based on those juvenile outmigrants and Bristol Bay run size. And it's a pretty good predictive relationship as we sort of think about the error and the different sources of information we have for predicting Bristol Bay run size. An R squared of 0.72 isn't so bad. So translating this in another way, I mean, we can kind of look at that juvenile index of outmigrants here, translated into adult returns in a couple of different ways, either in thousands or the natural log of that. in red and in green, and we can compare that to these gray bars. Those gray bars are the observed run sizes from 2005 up through 2025 here. And what we're seeing is that either way, we tend to see these forecasts. These are the forecasts that would have been made based on the high seas data, pretty well tracking the variation in run size we've seen across this period. So the mean absolute percent error is, 11 to 12%. What we see in terms of predictions out into the future. So one of the nice things about these juvenile data as a source of information for forecasting is that we get a picture kind of 2 years out into the future of what adult returns might be. We see that relative to 2025, the prediction for 2026, based on these surface trawl survey data, is somewhere down here between 43 and 45 million. 2027 coming back up. So our based on these surface trawl survey data through 2025, the predictions for 2026 and 2027 Bristol Bay runs are somewhere between 43 and 48 million. So kind of in line with the forecast that Chris just presented, these surface trawl survey data that are kind of an independent look at what might be coming down the pipeline in terms of future returns to Bristol Bay are suggesting something similar, a drop in abundance of returning fish in 2026. The other question is, of course, like beyond Bristol Bay as a whole, can we use, again, on the x-axis, this high seas index of Bristol Bay adult returns to predict run size by river system? So each of these panels is basically the relationship over that same period of time from the mid through 2000s up through 2025. Each point is an individual year. Up here, we have a description of the strength of the relationship. And what we see is that for quite a few of the river systems in Bristol Bay, when you try to sort of use these high sea survey data to predict run size at the river system level, it doesn't work as well. The exceptions are the Nushagak River, Ugashik, and to some extent Igagik, where you have a decent relationship. Some of the other ones, not so good. One of the challenges is from these surface trawl survey data, there hasn't been consistent collection of like genetic stock composition information. There's been sort of short-term studies, but that's something we're evaluating moving forward, whether or not there'd be some utility in that to try to improve the reliability of river system by river system forecasts based on these high seas survey data. So what have we learned, right? These surface trawl survey data provide a pretty good predictor of run size. They're able to do it, 2 years in advance, which is great relative to kind of our traditional forecast methods. It doesn't work so great at the river system level. But one of the other questions kind of I've been interested in is how well do these surface trawl survey data work relative to our, again, quote unquote, traditional forecast methods, kind of thinking about spawning abundance and sibling relationships and so on. So one kind of simple way to approach that question is to use what's called Bayesian adaptive sampling. And I won't go into sort of the background kind of mathy details, but basically what this does is creates a whole suite of models with different predictors and then looks at the inclusion probability for each of those predictors in across those range of models based on their predicted performance. And so it can be useful for this sort of hypothesis testing. Which of these predictors is more or less important in predicting Bristol Bay run size in this case relative to one another? How useful are they? And so just as a sort of fun initial test case, I looked at sort of three pieces of information. One, the spawning abundance in previous years for predicting Bristol Bay run size 4, 5, and 6 years down the line. The abundance of 2.2s and 2.1s and 1.2s and 1.1s, so those sort of sibling age classes that we would use to predict Bristol Bay run size into the future, kind of our standard sibling predictor age classes. And then our juvenile index or our high seas index of sockeye from the Eastern Bering Sea that we were talking about before, as well as sort of just the components from the 2 ocean and 3 ocean pieces of that. And so you don't really need to pay attention to the direction. They're mostly all positive, but the inclusion probabilities are really interesting, right? If the juvenile surface trawl survey data were far and away the best predictor of run size, that would have high inclusion probability, and some of our traditional sibling data would have very low inclusion probability. That's not really what we see. what we see is that there's information from juvenile high seas survey data. There's information from those 1-1 returns in the previous year and the 1-2 returns in the previous year and the 2-1 returns in the previous year, kind of our classical sibling information. So at the end of the day, it suggests to me that we need to be thinking about how we can kind of integrate information from both the service trawl surveys as well as our juvenile service trawl surveys, as well as our kind of traditional sibling-based forecast methods. And when we do that, we see that we get pretty good, this is within sample, but pretty good within sample predictive performance from this Bayesian adaptive sampling model that includes both high seas data as well as sibling data, error rates in the 7% range versus just with high seas data alone, you're looking at error rates in, the 12% range. So maybe a bit of an improvement there if we consider these side by side. So just some kind of general concluding thoughts. High seas survey data do provide useful information for our Bristol Bay preseason forecasts. And a huge thank you to NOAA and the Alaska Department of Fish and Game for being willing to share those information or those data with us for our forecasting purposes. But at the same time, both kind of the classical sibling relationships, the abundance of fish returning in prior years, predicting the returns of members of the same cohort that are returning after additional years in the ocean, still provide useful information along with environmental data. And probably the best forecast performance is coming from a model that includes both of those types of information. Real quick before I turn the mic over, I wanted to highlight a couple of the in-season forecast products that we try to put together each year. So during the season, there's really two pieces that we're working on. One is our basically daily update. So we have a website and you can download the PDF as well with just a subset of figures that we update every day, kind of comparing the current Bristol Bay run size to our preseason forecasts and past years. As well as our in-season forecast reports that are released about every 5 days and are a more comprehensive summary of kind of results of our overall forecast models and some interpretation of what we think is going on with the run in a given year. So feel free to track those. And of course, feel free to reach out anytime.
Thank you, Curry. Great, and I'll include those links to the in-season in the follow-up email. That is a great reminder. A few questions here in the chat, and again, feel free to raise your hand, anyone who wants to ask another one. And yeah, some of these relate more to you and more to Chris, so feel free to jump in as you'd like. I think, let's see, one I think I accidentally clicked answered, so I'll start there. But are the ocean conditions a factor when you look at assessing the fish size? In other words, are we seeing normal return in ocean temperatures that might be increasing our fish size, or is it strictly run size that dictates the fish size?
Yeah, and Daniel and a couple of his students have done some really interesting work looking at sort of the relationship between fish size, temperature, the abundance of pink salmon in the marine environment, and overall Bristol Bay run size. So competition being a factor, pink salmon abundance, again, from a kind of multi-species competition or interspecific competition level, as well as temperature. Those all seem to play a role. Sorry, Daniel, I don't mean to speak for you.
Yeah, the only thing I would add is that ocean temperatures affect fish size too, but with a smaller effect. And what we see is that really warm summers during their last growth season tend to produce smaller fish, but those years then translate into warmer winters, which gives a positive boost to fish. So the effect of sea surface temperature is almost a wash because the winter growth seems to compensate for some of the depressed growth during really warm summers.
Thank you. Oh, Chris, I saw your box light up, but I didn't hear you. Let's see, another question, I think was just clarifying, what is the brood stock year for the 3 ocean fish, I think probably that we're expecting in this upcoming season?
Yeah, so in thinking about fish that went to sea, right? So in 2026, these 3 ocean fish were probably from a brood year in 2023, 2022, and 2021, depending on Yeah.
Okay. And then last one I see here is when you release the in-season forecast updates, how does that compare to actual returns? When you come up with the forecast accuracy percentages, are you incorporating those in-season updates?
Yeah. So one of the things that when we make adjustments to our in-season forecast model, right, with sort of incremental changes to incorporate new information or treat the information differently, like the first step is to rerun it for each year and kind of every couple days throughout the season retrospectively and look at forecast performance. And so yes, so for each day in previous seasons, we have kind of the forecast error rate. And there's some years that any one particular source of in-season information really drug the forecast away from the truth. And so by including information from the preseason forecast as sort of our prior information on the number of fish that have arrived inshore in terms of catch and escapement, the signal of run timing from the Port Muller test fishery, as well as the abundance and age composition of fish from the Port Muller test fishery, and the size of fish. The hope is that across all those different sources of information, we can give our best estimate of in-season run size.
Great, thank you. I don't see any more questions right now, but don't hesitate if you think of one. So we'll transition over to hearing from Dr. Daniel Schindler. Daniel is a professor and a principal investigator with the University of Washington Alaska Salmon Program, with special focus on how aquatic ecosystems respond to changing climate and how land use interacts with fisheries. And today we'll hear from Dr. Schindler on the state of the climate in the North Pacific and Bering Sea and how that affects the Bristol Bay salmon. Take it away.
Thanks, Francis. Yeah, before I start talking about climate, I'll just make a plug for one other forecast product that we produce that is relatively new to FRI, and that's at the end of every season. Typically by mid-August, we've been producing a preliminary forecast for the following year. And the reason we can do that is by basically the 1st of August, we know with pretty high certainty how many total fish return to the bay, and we know what the aggregate age composition is. The run reconstruction hasn't been done, which allocates fish to individual rivers, but we can treat all of Bristol Bay as one big run and make a forecast for the following year. So I think we've done that 3 years in a row now, maybe 4. And I just want to put a plug in for that because I know a lot of people have been finding it useful as they start thinking about what they're going to do in the following year. And I think what we're seeing is that our preliminary forecast that we can release in middle of August is within a couple million of our eventual preseason forecast. So again, I just encourage you to keep your eyes out for that. Curry and Chris usually release that mid to late August, and we hope that that is useful to people who are starting to plan for 1 year in advance. So yeah, today the core of my presentation is just to give you an update of how the ocean's doing in terms of temperature and what sort of climate effects we're seeing in it over the last couple of years. I'm presenting, but Nate Mantua from NOAA, who's really the climatologist, provided a lot of feedback on this and his interpretations of what's going on. And let's see if I can. Okay, so just to orient you here, let's get my laser pointer going. So just look up in this top left corner, and what you see is the outline of Alaska. And then what's shown here are what we call anomalies. And what that's doing is asking for, at a certain point in time and a certain point in space, was the temperature warmer or colder than average? And this is an analysis that Nate Mantua did a few years ago. And basically, he asked, what's the sea surface temperature map in years when Bristol Bay salmon tend to have high survival when they hit the ocean as smolts, and compare that to the sea surface temperature anomaly map in years that had the lowest smolt survival rates. And we'll just go to the bottom here. You see a lot of blue and purple, which means that since between 1960 and roughly 2000, in general, smolts did not survive as well when they hit the ocean when the temperatures were colder than average. And during that same time period, smolts tended to have the highest survival rate, which translated into high recruits per spawner when coastal ocean temperatures were warmer than average. So over the last 60 to 70 years, basically the pattern we've seen is that when water's warm in the coastal ocean, smolts tend to survive higher with higher rates and we get bigger returns. So let's look at the last few years. Again, each one of this is not an average. In this case, it's the observed summer sea surface temperature for 21, 20, 22, 23, 24, 25. And the fish we're going to see this year in 2026 went to the ocean in 2023 and 2024. And if we just zero in on 2024, we see some blue in Bristol Bay for these temperature anomalies, which says that during the summer of 2024, Bristol Bay surface temperatures were actually a little colder than average. So that would have produced the two oceans that are coming back this year. And then if we go back 1 year to 2023, we see some blues and some whites, which means in 2023, the smolts leaving Bristol Bay rivers actually hit average to colder than average temperatures. And if we compare that to 21 and 25, both 21 and 25 were warmer than average temperatures. So the fact that our forecast for 2026 is a bit lower than it has been for the last decade corresponds with these cooler than average sea surface temperatures during the summer of when those fish migrated out of the rivers and into the ocean, which in the past has meant lower than average survival. That effect of the nearshore temperatures, which seem to be critical for smolt survival, need to be put in the context of what's going on in the Eastern Bering Sea more generally. So these are temperatures that average across the Eastern Bering Sea since 1950. And you can see there's a lot of variability here. But this last decade, starting around 2012, 2013, really was off the charts. Literally, they had to rescale their graph, and we saw temperatures jump up almost a degree Celsius. So that's a little over 2 degrees Fahrenheit since 2012 or so. The last couple of years, it's cooled off a little bit, but it's really clear that we're in a warmer climate regime now than basically the last 60 years history of Bristol Bay sockeye. The good news of that is that these really warm sea surface temperatures have corresponded to those really exceptionally high sockeye returns to Bristol Bay, suggesting that the temperatures are not yet so warm that we should be concerned for sockeye survival. If we go to the Gulf of Alaska, so this is where the smolts eventually end up. They migrate out of the rivers and they head west along the Alaska Peninsula. And then by the end of their first summer and into the first winter, they're down in the Gulf of Alaska, where they're putting on most of their growth in their second and third years. This has also seen this really warm period of time since about 2012, which has corresponded with not so great returns to rivers that drain into the Gulf of Alaska, but that's not what we're seeing in Bristol Bay. And the reason for that is really borne out if we compare the Bering Sea here in blue to the Gulf of Alaska. The Gulf of Alaska in general is about 3 to 4 degrees Celsius warmer than the Eastern Bering Sea. And it seems, based on our analysis of both growth and of year class strength, is the growth of sockeye doesn't seem to be impacted by these warm temperatures. And basically, the sea surface temperatures that Bristol Bay smolts are hitting is still in the quote unquote good zone. It's cool enough that they don't have reduced survival rates. I want to highlight one additional thing, which is that the North Pacific is warming faster than pretty well any other ocean in the world. This is a paper that came out just 2 years ago. And I want to look at this panel here in the middle. And the what's being plotted in blue or red are these anomalies once again. So if it's blue, it's below the long-term average. If it's red, it's above the long-term average. And starting about 2013, the North Pacific Ocean, shown here in red, really jumped up to almost a full degree Celsius warmer than it was historically. And superimposed on that in the black line is the global sea surface temperature. So for reasons that I certainly don't understand, that I'm not sure the climatologists do either, the North Pacific has really been warming up fast, faster than almost double the rate of the rest of the oceans globally. Something we need to keep in mind as we look into the future for North Pacific fisheries. Want to give you a bit of an update of how temperatures have played out this year over the last year, because some interesting things are going on in the North Pacific. So this is what the sea surface temperature maps looked like last June, about the time people were heading up to get their boats ready. And again, these are anomalies. And what we see that in Bristol Bay and the Eastern Bering, we see a lot of blue, which means these are colder than average for that time in that place. And the Gulf of Alaska is white, which means it's about average. And I'm just going to click through a couple time periods here. So this is the end of last summer, and you can see it's red everywhere, both in the Gulf of Alaska and in Bristol Bay. So by the end of last summer, things had warmed up to considerably warmer, like 3 degrees warmer Celsius. So that's almost 7 degrees Fahrenheit, warmer than the long-term average. So by last summer, as the fishery is winding down, sea surface temperatures were exceptionally warm. And then I also want to draw your attention to the equator here. So that's at 0 degrees latitude. And you see this big band of blue on the equator. That's indicative of what we call a La Nina temperature signal. And this was the end of a La Nina where the tropics are colder than average. And that's often associated with particularly warm temperatures in the southern Gulf, or in the mid latitudes of the North Pacific. And if we just step through into the winter there, this is what it looked like in around Christmas. Again, we see these cool waters on the equator, which people were predicting would be a La Nina. But it turns out that by mid-winter, that La Nina signal of that cold water on the equator was starting to disappear, and has become replaced with a band of really warm water that's starting to accumulate. So this is what the temperature map looked like on the equator just about a month ago, starting to show red, which is now the signature of El Nino signature. Interestingly, if we go up to Bristol Bay and the Gulf of Alaska, it's still blue. So I'll toggle back a couple. Even though it finished off last summer as exceptionally warm, it's been a cold winter in Alaska, and people who are up there can can verify that. But you can see the sea surface temperatures are blue off of Alaska starting around New Year's, and they've persisted into this spring. So things are still relatively cold up there. But the thing the climatologists are really keeping their eye on, and you may have heard this in the news, is this El Nino that's starting to develop. And if we look at just this is last week, I guess, and in fact, yesterday, we're seeing now this big band of really hot water on the equator, which has got the climatologists all excited because they're starting to predict a super El Nino. In Alaska and particularly in the Eastern Bering Sea, things are still much colder than average. The thing to keep in mind is that even though El Niños have big impacts on sea surface temperatures, particularly in California, where those warm temperatures result in really high rainfall. And then the flip side of El Nino is La Nina, which tends to produce really wet winters in the Pacific Northwest. The El Nino cycles have less impact in Bristol Bay. So as you're listening to the news and hear temperature reports about what the North Pacific is doing, you're going to hear a lot of excited climatologists talking about this El Nino that's developing. And historically, those have not translated into particularly warm summer temperatures in Alaska. That said, the forecasts that the climatologists have made for Alaska for this coming year, which are independent of the El Nino forecasts, are pretty warm. So this is now a temperature map that's making predictions for summer temperatures throughout North America. Here's Bristol Bay over here. And you can see that the models, these were predictions made around New Year's, I think. And basically, it's almost they're predicting with 70% odds, basically, that uh, Western Alaska is going to have warmer than average temperatures on land. And they've made similar forecasts with a different model for sea surface temperatures um, and what they're predicting as well. Here's that El Nino signal on the tropics. But if you look to Bristol Bay, they're forecasting that it'll be warmer than average, but not off the charts warm like they're predicting for the subtropical and temperate parts of the North Pacific. So to wrap it up, basically, what the climatologists have basically their communications coming out is that this La Nina that was persistent for almost a year and a half has faded away, and there's very strong odds of an El Nino developing. Um, and basically, whether it's a El Nino forecast or one of these other climate change forecasts, predictions are for an exceptionally warm spring and summer in Alaska, even though it's been pretty cold this winter. And that cold water temperatures have persisted into this spring. Ice is still on the lakes up there, and based on all indications, ice will be on there probably through most of May. But then the forecasts are that things are going to get warm in a hurry this summer. And I think that's all I have. Yeah, so that's what I have today. Happy to answer any questions.
Thank you. I see one in the chat here and welcome any others. Raise your hand or type them in. But one question I think is clarifying, is the corresponding warm ocean being positive for smolts considered just a correlation or is that a causation?
Yeah, thanks, Peggy. That is a correlation for sure. We don't really understand the mechanisms for why warmer temperatures would translate into higher smolt survival. Chances are it's probably because there's warmer springs translate into more zooplankton production, which allows them to grow faster. But yeah, you're right. It's basically a correlation, and we don't really understand the the mechanisms that produce that higher survival under warmer temperatures.
Thank you. Yeah, well, we can start the screen share switch over to Dr. Ray Hillborn, but welcome any other questions. Interesting to hear we'll see a little warmer water temps this summer. It's easy to think whatever's happening now, which has been such a cold winter up in Alaska, will continue, but that is good to know. Here, another question here. Is there any correlation between Bering Sea SST and run timing in Bristol Bay?
Yeah, Curry can probably answer this better, but that's an interesting thing is that the run timing of the rivers is pretty stable. It varies a bit from year to year, and it certainly varies depending on which river's coming in strong. But the run timing has not really changed much as the ocean has warmed up.
Yeah, I'll just add to that like one of the best predictors of run timing that we're finding with some recent research is looking at actual sea ice extent in the spring and into May. And you tend to have this negative relationship, the basically the longer or at least the more sea ice that's out there, the earlier the run timing seems to be, which is an interesting relationship, but it's pretty consistent across the different districts in Bristol Bay. So sea ice, and again, correlative seems to be a better predictor of run timing than sea surface temperature.
Thank you. A couple other questions here. I guess this one's for Dr. Schindler from Margie Bauman. Is this an indication that there is still sufficient food for smolts in the ocean?
Yeah, the question is there sufficient food for smolts? I mean, that's an interesting question because um, you know, analyses by various groups have shown two things. And basically you can ask the fish, what are the food conditions that they've experienced? And during this period of really large sockeye returns to Bristol Bay, fish grew slower. And that's because there's more hungry mouths within the Bristol Bay population of sockeye, and they're competing more with each other. So there's got to be less food per individual. Superimposed on that is the fact that we've seen this massive buildup of pink salmon and chum salmon at the scale of the North Pacific, and the growth rates of sockeye is definitely depressed by chums and pinks. So there's less food to go around now per individual Bristol Bay fish than there was, say, 30, 40 years ago. And a lot of that is competition with pinks and chums, but some of it is just competition with other Bristol Bay fish. But yeah, as Chris pointed out, we're expecting to see a little bit bigger fish this year, both because there's a healthy return of three ocean fish coming back, but also because there's fewer of them, they should grow a little faster.
Interesting, thank you. Question here says, why is Kujak so off? I'm not sure if that's the forecast or what that means exactly.
Can you clarify that, Kieran, in terms of off and size of fish or number of fish? Oh, why is it producing so few fish compared to its historical? Yeah, that's a good question. Not sure we have a clear answer to that one. I mean, Kujak used to have that very strong cycle, and management actually managed for the cycle. So in peak years, there were higher escapements. That's less so these days. Curry or Ray may have a better answer to that.
Yeah, I think in general, there's been quite a few hypotheses about what changed that led to the reduction in sort of the pronounced 5-year cycle in the Kujak. Just in terms of our low relative forecast for Kujak this year, that's just primarily driven by the age composition of fish that returned to the Kujak last year. So it just suggests that we're likely to see fewer fish than we might have in recent years.
Thank you. Great. Well, let's transition to hearing from Dr. Ray Hillborn, but keep the questions coming. We'll have some more time at the end to revisit any of the presentations as well.
Okay, I'll start my presentation now.
Go ahead.
My presentation here. Well, I've got to. I'm on the speaker here. Okay, sorry. This is a reasonably short presentation, just to go up to a high level and talk a little, give people some background on escapement goals and some of the issues associated with escapement goals, because I'm sure, as you all know, that the whole management system is driven by monitoring the number of fish that come in and opening and closing the fisheries in order to try to have the number of fish counted up the rivers fall within the range of desired escapements. And the Alaska Department of Fish and Game has a structured program of different kinds of escapement goals. The sort of the basic one is the biological escapement goal, and that's really built around the desire to maximize the long-term harvest or the maximum sustainable yield. And a biological escapement goal is the escapement that, in theory, produces on average the highest long-term average yield, not the highest long-term return, but the highest long-term yield. Then there is the sustainable escapement goals that have been historically shown to provide good yields over a 5 to 10 year period. That's more somewhat subjective. You just look back and say, okay, we've had this level of escapement as the fishery performed well, and it can be, you can have a sustainable escapement goal because you may not have the data available to do a biological escapement goal, or you may have a sustainable escapement goal because there's just a lot of, say, uncertainty in the biological goal. And then finally, there's the optimal escapement goal, which may be set for other reasons, such as allocative factors, concerns about having higher or lower escapements impacting the ecosystem. But the basic most escapement goals for the well-studied streams have been based on biological escapement goals. And it assumes that as spawning increases, the habitat limitations, either in the terms of spawning area or food, will start to reduce the survival of fish. Because if you don't have that, if you're not limited by spawning area or food, and you just put more fish on the fishing grounds and you get more back, then essentially there's no limit to how many fish you should allow to spawn, and your escapement goal would be very large. So you end up really asking, at what point, as you have higher escapements, does the average survival start to decline? Not the average total return, but just the average survival, the number of fish returning per spawner. And the biological escapement goal is the point at which one additional fish sent to spawn would return one additional fish in the future. So you're saying, should we catch this fish now, or should we let it spawn? And if it's going to produce less than one, then you should catch it now. If it's going to produce more than one, then you should let it spawn. And that's the key to the biological escapement goal. Now, in implementing it, Fish and Game uses a range for a biological escapement goal that is the range that would produce 90% of the maximum. So it'll be higher than your point estimate of the biological escapement goal, and it would be lower, but it would encompass that 90% range of maximum yield. So as example, here's data for the Wood River. This is the number of spawners on the x-axis, the number of recruits on the y, and the black line is the fit of what's the standard model through that data. This thing's called the Ricker model. And this area shaded in the green, which goes from about 1.2 or something to 3.4, is the range of a biological escapement goal for the Wood River system. And the biological escapement goals, where they're implemented, are updated periodically by Fish and Game. The same thing here for the Naknek River. And the thing you have to notice is there's enormous variability. You know, if you had 2 million spawners in Naknek, some years you've got 13 million back. Some years you've got only about 4 million back. But when you do the statistics, you get a curve that looks something like that. And again, you've got this pretty broad range where you get within 90% of the maximum yield on average. And so that's why under strict biological escapement goals, you will see a pretty broad range. But what about economics? Because, yeah, I mean, everybody's out there to catch fish or to process fish, but at the core, you're really trying to make money. In general, we've found historically in Bristol Bay that with the price of fish is lower when runs are large, and the price of fish is higher when runs are small. So what that means is that the value of, if you're interested in maximizing the value of the catch, then the escapement goals are a little bit different. Essentially it's the value, if the value of catch is maximized by an escapement goal, typically that is lower than the escapement that would maximize the number of pounds. Because the logic is, imagine you're in a very poor return year and the price of fish is super high. Then we make this trade-off. Should I catch that fish now or should I let it spawn? This is essentially the manager's decision that if it's worth twice this year than what you would expect it to be worth in the future, then you would harvest it. And the result is that if you're trying to maximize the value of the catch, you would actually have lower escapement goals than you would if you're just trying to maximize pounds. And yeah, so you trade off one fish now for one fish in the future, where that additional fish in the future, if a current fish is worth twice as what you would expect future fish to be worth, then you would want to see two fish produced for every fish you're going to let spawn rather than one. Now, what happens if you think about subsistence? And it gets even more complicated, because to a subsistence user, the first 100 fish are almost certainly worth more to them than the difference between 10,000 and 10,100. But biological escapement goals assume that there's no difference between in terms of the value to the fishery of 100 of moving from 0 to 100 to moving from 10,000 to 110,000. And again, this means that if you want to maximize the subsistence value, you would allow some fishing far below the biological escapement goals. So currently, for Bristol Bay, the Board of Fish has not set biological escapement goals, but it has set them starting in 2007 as sustainable escapement goals, simply because the biological escapement goals suggested that the escapement should be much higher than they currently have been. And economic analysis indicated that essentially the fleet and the processors would be better off with the sliding scale, which has now been implemented. And the FRI program did most of the analysis. Curry was involved in doing this back in the day. And so they moved from the left-hand side were what the previous escapement goals had been. And those were, I think they were at the time considered biological escapement goals. They moved to the sustainable escapement goals. And the big difference is that it's a sliding scale that's quite a bit broader. It allows for quite a bit higher escapements in years of big return. So it's a sliding scale. The manager is directed to aim for the lower end when it's a weak run, aim for the upper end when it's a stronger run. And that, so the big difference there, the lower bounds went up a little bit, but the upper bounds went up quite a bit. And it was explicitly a sliding scale that, depending upon what the run is, you aim for different parts of that range. So what about subsistence? It's generally not an issue in Bristol Bay. There's been plenty of fish for subsistence users. And AYK is where there's been very, very severe subsistence closures in recent years. And there's been a lot of a discussion about a much more sliding scale, because many of the escapement goals in the AYK region are based on biological escapement goals, that is, worried about maximum sustainable yield, not accounting for the fact that the first thousands of fish are worth much more than when you have a big run and adding another 1,000 fish. So that's just a background on escapement goals. And if there are any questions, I'll take them.
Thank you. That's great background. I know there's probably extra attention on that this year with our Board of Fish cycle. Any questions for this most recent presentation, or one of the past ones if something else has come to mind? Well, I will start my thank yous, but feel free to chime in if you think of something else. Thank you to our presenters. I really appreciate you guys taking the time to make this information accessible to the fleet. I know I absorb it a lot better hearing from you and having the opportunity to ask questions rather than reading a report or seeing things online. Yeah, Curry.
Oh, sorry to interrupt. I just wanted to give a huge thank you to our partners and colleagues at Fish and Game and at NOAA, who, are both collaborators in research and do a lot of the groundwork in terms of data collection to make some of this forecasting work possible. So thanks.
No, thank you for that. Yeah, it's pretty impressive how much work goes into these numbers that we pay attention to as fishermen. Well, I will pass it on to Lilani to give our final remarks. But yeah, big appreciation to those of you who called in and to our presenters. Go ahead, Lani.
Thanks, Francis, and thank you again, everyone who presented today. Just a few upcoming dates. A week from today, on Wednesday, we have a board meeting, which will be a virtual one. It starts at 1 p.m. Alaska time. And then May 19th, there's a virtual and in-person option to do a lunch and learn at UAF campus in the Margaret Wood classroom in Dillingham. That's with Sea Grant, and I'll be presenting and speaking to a lot of the projects that the BBRSDA is working on. June 9th, we are having a fleet event at the Willow Tree in Dillingham, as well as June 11th, we'll be in Naknek at the Pit for a fleet event. And you'll also see a handful of us visiting the Bay. June 13th through 16th, we'll be with chef partners, and July 6th through 8th with some of our retail partners. So look for more info on our website, on socials, as well as our waypoints that will be going out monthly. And that is it. Thank you, everyone. We have 7 minutes left that we allotted, and we're happy to give you back that time. All right. Cheers. Have a good season.